Alright, so we're going to talk about why do we need an instrument rating, right? Alright, so when do you need spread this out. Alright, so when do you need an instrument rating? Alright, so when do you need an instrument rating?
We need when we fly to instrument flight,
Okay, when else? So an IMC,
IMC.
when else? Do you have the red book? You don't have the red book?
No.
So you don't have this book right here?
I'm gonna put it about the handbook.
Yeah.
Should I study that thing?
Yeah, you should be studying everything, man. What are you not studying? You're not studying nothing?
No, not the red book. I haven't studied that.
You have this
Check
book?
writing. Oh, that's for check writing.
This is for everything.
Yeah, yeah.
Do you have this book?
Yes. In my
You ever,
room.
have you ever read it? Has a lot of questions in here.
Okay. I have this book.
You should read this book.
Okay.
Alright, so when do you need an instrument rating? So IMC, not just IMC, there's more. So, if you're
Flight.
a commercial pilot, you need an instrument rating to fly more than 50 nautical miles at night with passengers or cargo.
More than 50. Yeah.
When else do you need an instrument rating? Do you know when else? No? Okay. So you need it for special VFR at night in controlled airspace, i.e. class Bravo, Charlie, Delta. And you should know this one right here, the last one. You should know this one. When do you need an instrument rating? In class Alpha.
Oh, class Alpha.
airspace.
Yeah.
Right. You should know that.
Yeah.
So this is when you need an instrument rating.
Okay.
So this is the key question right here. And another key question that you need to know is how to stay current as an instrument pilot. So now you have the rating.
Okay.
Okay.
Current
So how do you stay currency?
six.
So what does that mean?
6 calendar months and 6 instrument approach. Holding procedure, intercept and track course through of use of electric navigation system.
So within the preceding 6 calendar months, you need to log 6 instrument approaches, which consist of holding
holding procedure.
intercepting,
And
and
track,
tracking.
tracking course.
Use of using systems, navigation systems, right?
Yeah.
Navigation. Right?
Yep.
So now you have the instrument rating, right? This is how you stay current. So what if it's been more than 6 months? Let's say it's been 2 years.
Why did you say special BFR E9? What does that mean? Oh, at night.
You need a flight review.
Okay, we're past private pilot already.
Okay.
So it's been a year,
In the year.
or a year, 2 years since we flew an instrument. How do we get back current? We need to have an instrument, an IPC, right?
Yeah.
An instrument proficiency check. What is that? You know what that is? It's on that packet that I gave you. It's on the first page.
Yeah.
It's at the bottom. On the right.
So.
Should be, or it should be at the bottom.
Oh, the instrument personal check.
Should be at the bottom on the right. Keep going down. Should be on the right.
What's class? Is that all class A? AS by 6,000 a month?
Yeah.
No, this is
Look back, 12 calendar months not current. You need an instrument precision check (IPC) by a double examiner or approved person.
right. So you need to get an instrument proficiency check. That is your flight review for
Flight
an
review.
instrument rating,
Okay.
right?
Yeah.
So if it's been more than a year, right?
Yeah.
You need to get an instrument proficiency check. Now, what is that? This can't be. You can't go out and do this, right? You need somebody else to be there.
Mhm.
Right? So you can't go get a safety pilot to do it. You need a CFII. You need
Examiner.
a
DP
DPE or an approved
person.
examiner.
Yeah.
Alright? So that's how you get proficient after a year. So it's been 6 months. Let's say you waited a year, right?
Yeah.
And now you're like, oh man, I'm not current anymore. So now you have to go find somebody, right, to get your instrument proficiency check, right? The 3 people that can do it, a CFII, DPE, or approved examiner. Now, what is on an instrument proficiency check? What's on it is basically, it's under 6156, I believe. So 61, 56, and 57.
Yeah.
Now, 6156 should be the flight review, and 6157 should be, I forget the other one. It's one of these two, both of these actually. So one of them is currency and, excuse me, one of them is flight review, and I forget what the other one is, but both of these regs you need to know.
Okay.
And then it's actually listed what the instrument proficiency check is on. And it's basically, it needs to be use of, it's basically this right here, the 66 hit, but it's more information. So you have to do emergency procedures as well. It's not just the navigation portion and the holding intercepting, but it's more to it. All right, so that's it.
Yep.
All right. Cool. Any questions?
What's the IPC instrument proficiency check? 1 year for that?
So you know how you, for
Okay.
private, it's the 3 takeoffs and landings, right?
Mm-hmm.
So after that, let's say it's been 2 years, right? You have to get a flight review. This is the flight review for instrument.
Every year.
Not every year.
How come it says 1 year?
This is over, so it's been passed outside outside of currency. This is outside of currency.
Okay.
All right.
Mm-hmm.
Cool. Good.
Cool.
Wait, don't erase the bottom part, the IPC part. IPC part, hold on. Did you also get a message?
No, I thought it was.
So it's legal or IPC before IPC was
1 year.
1 year.
So it should be more than a year.
Okay.
So more than a year.
More than a year.
More than a year.
Okay. So IPC is flight review for IFR.
Right. So it's called an instrument proficiency check. But everybody can't do it. Only a CFII, DPE, or an approved examiner can do it.
Okay.
Right? Make sense?
Yep.
Okay. Good?
Good.
Gonna erase this.
You said CFI?
CFII.
Oh, CFII.
Yeah, because it's instrument.
And
right?
an approved examiner.
Or DPE.
D.
So if you go do it, basically, if you go do, like for me, when I did my II, if I hadn't had an IPC, the DPE could have given me the endorsement at that moment, and it could have reactivated my instrument currency. Good?
Good.
Okay. Alright, so now we're gonna go out and navigate through it, right? So tell me, what are the instruments on the pitot static system?
Instrument airspeed indicator, altimeter, and vertical speed indicator.
Alright, so we have
So if Richard asks me this question, can I draw a picture for
You
him?
should, yeah,
Okay.
if you can draw it, that's great. Alright, so these are the instruments on the pitot-static system, right? We have
Yeah.
our airspeed indicator, our altimeter, our VSI, right?
Yeah.
So how does the airspeed indicator get its information?
Get the information.
Yeah, how does it get its information?
Peter most.
How does it get its information?
It has a pitot tube.
Just the
It's a
pitot tube?
Connect with pitot tube.
So remember, on the Diamond 20, it's like this, right? So we
Yeah.
have this on the Diamond 20. Alright, so this is what it looks like on the Diamond 20. We have a pitot mass. So we have the ram air, static air, and then we have the drain hole. Right?
Yes.
So this is the Diamond 20. This is the traditional, like Cessna 172. So this is the Cessna 172, and this is the DA20, right?
Okay.
Make sense?
Yes.
So you need to know the traditional, and
Okay.
you need to know both,
Okay.
right? So, how does the airspeed indicator get its information?
Good. Its pitot tube is open, and the air is moved into the tube,
And so it's just from the pitot tube?
and static
Right, so it gets ram air.
air.
So ram air goes through the pitot. Oh, I already got it written there. Pitot tube, right?
Yeah.
Alright, so then it gets the static air, right? From the static source, right? So on the Diamond 20, same thing, right? Ram air. So this is our pitot mass, right?
Yes.
It looks like that. It looks like a little upside down, whatever that thing is, right? So we've got the ram air, right? We've got the static air on the back of it, right?
Yes.
And on the bottom is the drain hole.
Drain hole.
Right? So, this is how it gets its information. Now, I'm going to kind of fast forward a little bit. So, on the inside of the instrument, what information is the airspeed reading? Yeah, so on the inside of the airspeed indicator, what information is going on? Like what's this on the inside of the airspeed indicator? What instrument is on the inside of the airspeed indicator? It's called a diaphragm. Remember that? You remember that from ground school? Diaphragm.
Yeah.
So diaphragm, right?
Yeah.
So, what information is this airspeed indicator getting? It's getting information from the pitot tube, and we said the static port, right?
Yeah.
So, the pitot tube is connected directly to this diaphragm. Inside the casing of the instrument is static air, right?
Yeah.
Now, how this information is being read, it's basically taking the difference between ram air and static air, and it's giving us dynamic pressure. Does that make sense? So it's the difference between ram air and static air. Ram air, static air, and it's giving us dynamic pressure.
Yes.
Does
Yeah.
that make sense?
Yeah.
So this is the airspeed indicator. So it has a diaphragm, right? So
Yeah.
think about it like you're inside your chest right here is a diaphragm. So as you breathe in, breathe out, it's able to, this one doesn't expand and contract, but it's able to gain a reading off of this, right? So it's air being forced into this diaphragm, right?
No.
But inside the casing, we have static air, right? So it's able to give us an indication, right? So what are the different types of airspeeds?
Different type.
Different types of airspeeds.
What is
Different types of airspeeds.
VX, VY?
No. Different types of airspeeds. Not airspeed, not
The number. Yeah, the
no. So we have indicated airspeed. So
okay.
there's an acronym. So ICE TG. I'm not going to talk about E, but we're only going to focus on these.
Okay.
All right. So ICE TG. All right.
STG.
So it's indicated airspeed. What is indicated airspeed?
The airspeed, just the airspeed indicator indicates the number.
Right. So it's what we read off the instrument, right?
Yes.
And then we have calibrated airspeed, right?
Yeah.
What is calibrated airspeed?
Corrected for instrument error.
Right. So it's indicated airspeed corrected for position error.
Position.
So what we read off instrument indicated corrected for position error. What's true airspeed?
True airspeed is no temperature.
You said it. Keep going. So it's corrected for
no temperature.
non-standard
No, yes.
temperature. What's
Yeah.
ground speed? What's G?
G, ground speed.
So what is ground speed?
Speed over the ground.
Corrected for winds.
Correct for wind.
Yeah, winds, right?
Yeah.
Okay, so this is
Table
airspeed,
speed, yeah.
right? So, keep going. Alright, so what information is being read off the altimeter?
Just static source.
So it's being read from the static
Static
source,
source.
it's giving us altitude, right?
Yes.
And
VSI, we need
where does it get its information from?
static.
Static source, right? And then what does the VSI give us?
Vertical speed.
So it gives us rate of
yeah.
climb, rate of climb. Right? So
Yeah.
this is it for airspeed. I'm gonna erase this. Are you good with this? I'm gonna take a picture of it. You have it on your iPad, so are you recording me? So,
Yeah.
Alright, so if you have it there, then you can take a picture.
Okay.
Cool?
Cool.
Alright. So I'm just gonna erase this bottom part right here. Are you good?
Yeah.
Alright, cool. So that's it for the altimeter, alright? So let's talk about the airspeed indicator. Now let's talk about the altimeter, right?
Yeah.
So, the altimeter. So, the altimeter, oops. Gets its information from the static source, right? And this is our altimeter, kind of a basic drawing, but what we need to know, it has, what does the altimeter have inside of it?
Have
What instrument is inside of the altimeter?
Linkages.
Aneroid
Wafers.
wafer,
with
right?
Yeah.
Aneroid wafer, right?
But isn't the aneroid wafer and the diaphragm the same thing?
It is the same thing.
Yeah.
It's just
Different.
no, it's not different. It's
The same
basically
thing.
like,
Same thing.
it's basically like tomato,
Okay.
potato, potato.
Yeah.
Okay.
Yes, basically. So it's the exact same thing, but it's just a different name for it, right? So same thing, expands like your lungs and contract, right?
Mm.
So think about it like this. Altimeter is basically this right here. It's a balloon, all right? There's Edwin, he's holding a balloon, right?
Yeah.
So it's basically a balloon, right? Expands and contracts, just like a balloon does, right? So as we climb and descend, this is what's happening, right? So as we climb, right, the pressure is lower, right? Lower pressure as we climb, right?
Yes.
So this static source is just providing a lower pressure, right? So as we climb, the air is less dense, right? This instrument is going to contract, right? So it's going to indicate a climb,
Yes.
right? Now, how does this instrument indicate our actual altitude? You ask. It has what they call a
Linkages.
Kollsman
Window.
window. We got to go back. We forgot one thing earlier. We'll talk about it later. I got to write it up here. So, equipment. Forgot about that. All right. So, Kollsman window
Yeah.
is basically a pressure sensitive altimeter, right? Kollsman window. Kollsman window? It's
Yeah.
a little dial right here, right? And we set it, right?
Yeah.
To whatever the current pressure is, right? So if we're flying above flight level flight level 180, the pressure will be set at 29902, right? So this instrument is basically reading pressure based off what we set it at. All right? Does that make sense?
Yes.
Cool?
Cool.
All right, so that's pretty much it for the altimeter. Okay, so the different types of altitudes. All right, so what are different types of altitudes? We have pressure altitude. We have, oh my gosh, true, absolute density. I think this is all of them. I've forgotten now.
Pressure altitude. This
All right, so what's pressure altitude?
pressure altitude
So it's
indicates
the height
the altimeter.
above the standard datum, which is 29902.
2. Yes.
All right, what's true altitude? Height
Actual
Above sea level.
actual height above MSL.
above MSL means sea level, right?
Oh, yes, MSL.
So what's AGL? Or excuse me, what's absolute?
just is
height
above the ground.
above ground, right?
Yeah.
What's density altitude?
Pressure altitude correct for non-standard temperature.
So pressure altitude
You need density of
corrected for
Non-standard
standard
temperature.
temperature.
Yeah.
Am I forgetting one?
Indicate.
Indicated altitude. I don't think that's one. Cool. Any questions? We'll take a picture.
Yeah. Okay.
Cool. All right, moving on.
Hey yo, don't delete that please.
Just take a picture. It's easier.
Yeah.
Or send him the picture you just took. Send him the picture. I erased half of it.
Okay.
No, that's cool, I got it. Got it.
Okay. All right. So VSI, right?
Yeah.
All right. What is a VSI?
Vertical speed.
Vertical speed indicator, right? So same thing, all right? VSI, all right? So now we have a VSI, right?
Yeah.
So what does a VSI give us? Rate of climb, right?
Yeah.
All right, same thing now, right? So let's go back to the original picture, right? So VSI, right? We have a diaphragm inside of it now, right? Same deal. As we climb, it expands and contracts, right? The only difference between this instrument and the altimeter is that this one has what they call a calibrated leak. What is a calibrated leak, you ask, right?
Yeah.
So, we mentioned earlier, right, as we expand, as we climb, right, the pressure is lower, right? The instrument is going to expand and contract, right? Same deal here, right? Now, if it only did that, it would be nothing more than another altimeter, right?
Mm.
But this one has a calibrated leak, right? So what happens when the pressure actually stabilizes in this casing? So let's say lower pressure goes in, it's now being replaced with the higher pressure that's in here. The higher pressure is going to leak out, right?
Yes.
Once it leaks out and stabilizes, this instrument is now able to give us a rate of climb, right? Now, if the instrument reads that the same pressure is coming in that's already inside the casing, it's going to indicate no climb,
No climb. Yeah.
right? It's just going to say 0. We're not climbing, straight level, right? Now, but if the pressure comes in now, it's higher than the pressure that's in here,
Descent.
It's gonna indicate a descent, right?
Yeah.
Because now we're descending, right? Same thing. So, this instrument is nothing more than an altimeter, but it has a calibrated leak inside of it, so it's able to give us rate of climb
Okay.
and rate of descent. Now, when we do our instrument cockpit check, what are we looking for when we look for airspeed? What are we looking for?
Looking for.
So the airspeed needs to read 0, right?
Yeah.
What about the altimeter?
Oh, within 75 in of the aviation field.
Right, so within within 75, so
Field
plus or
aviation.
minus 75 feet.
Yeah.
So read 0. What about the VSI?
0.
0, right?
Yeah.
Needs to read 0, or
3.
if it wasn't 0, we would note position as 0. For example, if this read
7.
100 feet, let's say instead of 0, it read 100 feet per minute, right?
Okay.
And it was just stuck at 100, right?
Yeah.
We would just say 100 feet is now our 0, right? So straight and level is going to read 100 feet.
100 feet. Okay.
All right. Cool. Any questions? Nope. All right. So this is it for the pedostatic system.
Yeah.
All right.
Yeah.
Gonna move on.
Is this what they ask in instrument?
This is stage 1.
Okay.
Stage 1 flight.
Okay.
Stage 1 ground. I think it's the same. I don't know.
So you think this is what Jacob's been teaching?
More than likely, yeah. All right. So that's it for static system. So we have some other instruments we need to talk about, right?
Need a new mark.
We need to talk about.
I need a new board.
Oh yeah.
Mhm.
We need to talk about
Gyroscopic.
the gyroscopic instruments, right?
Yeah.
All right. So we're going to talk about the attitude indicator. We're going to talk about the heading indicator. We're going to talk about the turn coordinator. All right, so these are our instruments that operate off the gyro, right? So our gyroscopic instruments. All right, so attitude indicator, right?
Yeah.
We've got the little this, plane, blah, blah, blah. All right, cool. So, what are the principles of a gyro?
Oh, gyro principle 2 type is
So
one is
principles
rigidity in space and position.
of a gyro of a euro. So, rigidity in space, right?
Yeah.
In space,
And position.
precession, right? So, what is rigidity in space?
I know the attitude indicator and head indicator.
No, what is rigidity in space? Not what is that. What is rigidity in space?
I don't miss.
Think about the name. It says rigidity in space.
Yeah.
That means that it doesn't move.
That it
It's
doesn't.
fixed in place.
Oh, is that
It's
what the word
rigid
means?
in space. Yeah, rigid in space. Does not move.
That doesn't.
Is that attitude indicator?
No, we're talking about principles of a gyro.
Yes.
Or principles of a gyro?
So it does not move. Rigidity in space. Now, these instruments operate off of the vacuum system,
Yeah.
except the turn coordinator. This is off
Electric.
the electrical system, right?
So rigidity in space just means it doesn't move.
It's fixed in place. Fixed in space.
Oh,
Think
fixed.
about the name.
Okay.
Rigidity in space. Doesn't move.
It's
Fixed in
rigid.
rigid in space. Right? So, here's our gyro, right?
Mm.
So, our gyro has what they call gimbals, right? So, it has two gimbals. So, two gimbals. Basically, it's one gyro, two gimbals. So, it has this gyro here, or this gimbal here, this gimbal here. One gimbal is for pitch, the other one is for bank.
Yeah.
Now, think about it like this. How our gyro stays fixed in place, right? It's just like this, right? The side of the gyro looks just like this. It looks like little teeth, right? The vacuum system, right, actually provides air into, so it's just two ports, right?
Mm-hmm.
Air in, air out. Right? So it's forcing air in and it's sucking it back out, right? That's how the air is grabbed on the side of these teeth, right? So it's being pushed in and pulled out,
Yeah.
right? So that's what keeps the gyro spinning in place. Fixed in place, rigid in space, right? So, what is precession?
Gentlemen, move.
No. So, Newton's third law. What is Newton's third law?
You put force on side and this side gives another
Right,
force.
so for every action, there's an equal and opposite reaction, right? So if this was spinning like this, right?
Yeah.
If I hit the top of this marker, right, the force is actually going to be felt 90 degrees ahead of its rotation plane, right?
Yeah.
That's what precession is, right? So you can actually test this by, I don't have the bike wheel, but if you spun the bike wheel, right?
Yeah.
And you hit the top of the bike wheel, you actually see the wheel move at the end of it, just like your propeller blade, the same thing, right? That's why we have to add right rudder, right? The propeller is nothing more than a gyro,
Yes.
right? All right, cool. Bring it back to this, right?
Okay.
So, precession. Does the what instruments now operate off of precession?
The turn coordinator.
Okay, so turn coordinator operates off precession.
Yes.
Now, which one operates off of rigidity in space?
Attitude indicator and height indicator.
So rigidity in space. Rigidity in space. Right, so how does the attitude indicator, does it ever, first of all, does the attitude indicator ever precess? Okay, so does the heading indicator ever precess? Let's start there.
We think we need.
No, does it ever precess? So it's a question.
We
Does
need.
does the heading indicator ever precess? Yes or no?
I can't remember.
Wait, what did you say precession was again?
So precession is force applied,
X 90 degrees from.
felt 90 degrees ahead. Rigid in space. Fixed in space. Fixed in place. Alright, so does the heading indicator ever precess? You should know this.
30.
No, does it, it's yes or no. Does it ever precess?
No.
Yes, it does. Why? So it does precess, right? Because
Yeah.
you have to reset. First of all, how does the heading indicator give us heading?
Give the magnetic. How do you?
So we set the heading indicator to the magnetic compass, right?
Yes.
Mag compass, right? So we set the heading indicator to the magnetic compass, right? So this is nothing more than a slave to the compass, right? It's fixed. It's basically set to the compass, right? Now, my question was, does this ever precess? It does, right?
Yeah.
Because we always have to reset it, right?
Yeah.
Why does it precess?
Because different
Magnets
pressure.
and all
Because of
We
that. All the electronics in the plane. the
Because of
magnets.
precession, right?
Yeah.
Right. All right. So precession occurs because of the vibration of the aircraft, right? So the airplane just vibrates like crazy, right? So it's gonna cause the magnetic compass or the heading indicator, the gyro inside, to precess, right?
Just
Now-
a weird question. Do planes like jets, airliners, do they precess as well?
No, because they have HSIs.
What's that?
Traditional heading indicators.
What's an
Um,
HSI?
Heading something indicator. I forget what it stands for.
Okay.
But no, they don't precess. Yeah, it's just the traditional one does. What was my question? All right, so does the attitude indicator precess?
No,
Why not?
because rigid in space doesn't move.
I thought this one was rigid in space.
Oh shit. Well, it's got gimbals. Oh, got gimbals.
They both have gimbals. Okay, so there's something inside the attitude indicator called a pendulous vane. Right? So, the pendulous vane is this. There's something that holds the gyro in place, right? I'm gonna kind of draw it a little bit bigger so you can see, right? So there's a little door that opens up inside the portion of the gyro that keeps it fixed in place, right? That the gyro sits on. There's a door right here, right? When this door opens up, it actually will shoot out air out of this door, right?
Yeah.
And what if the gyro were to start precessing, the air would push it back up and fix it back in place, right? So this is called pendulous vanes.
Why not put a pendulous vane inside?
That's a
the
great
heading
question.
indicator?
That's a great question. The reason why I think they don't is because you wouldn't be able to set it. It would probably go right back to the same position.
Oh,
Yeah.
okay.
This is just from my observation. All right, so heading indicator, right? So both of these operate off of rigidity in space, but both precess. One doesn't precess because it has what they call pendulous vanes, the attitude indicator. Now the heading indicator operates off rigidity in space that's aligned with the mag compass that we set, right? Now, what's another error from the heading indicator? Why we have to reset it all the time? So we have to reset it because of precession, right? And there's also some other things. We'll just name one more for time's sake. It's 9 o'clock.
Wait, what's another error for?
All right, it's because of the Earth, right? So
Wait, what error are we talking about?
talking about the heading indicator.
Okay.
All right, so even though, let's say that the heading indicator never precessed, right? Because if you fly 390 Juliet Alpha, 699 Whiskey Bravo, those planes, the heading indicator almost never precesses. You rarely, every once in a while you have to reset it, not that often, right? Like say you're flying like 141 Bravo Bravo or 143 Mike Alpha, it may precess a lot, right? Now, the reason why it'll still precess, even if it didn't precess, let's say that it never precessed, right? We would still have to reset it. Why? Because the heading indicator doesn't actually seek true north like the compass does, right?
Yes.
So, because of that, it won't always read the correct heading. And another reason why is because of the Earth's rotation. So the Earth rotates 15 degrees per hour. Right? It rotates 15 degrees per hour. Now, if the heading indicator were to never precess, it would still be off at least 15 degrees every hour, which would be roughly, I don't know, maybe 1 degree, half a degree every minute or something like that. So it would still be off 15 degrees per hour. Right? All right, cool. So let's get on to these are the vacuum driven instruments, the attitude indicator, heading indicator. Now, some traditional aircrafts, the turn coordinator can be vacuum driven, but in our aircraft, it's electrically driven. Now, we have the turn coordinator, right?
Even in the 40, it's electric.
In the 40, everything's electric. The standby instruments, the attitude indicator is electric. There's only 3 standbys: the attitude, airspeed, and altimeter.
So the airspeed is electric.
No, I said the attitude's electric, the backup one. But everything is, the G1000, it's all electrically driven. All right, so the turn coordinator, right? So we have the turn coordinator. So what did we say this one operates off of? Precession, right? Now, what's special about the gyro inside the turn coordinator,
It's electric.
right? So what's special about it? Does it look just like these?
No.
What's special about it?
No.
It's what they call canted, right? It's canted, right? Kind of looks like that. My drawings aren't great. So canted, right? Canted gyro. What does canted you mean? So it's at an angle, right? It's angled 30 degrees. Why? So it's angled 30 degrees on the lateral axis. Why? Why is it canted 30 degrees on the lateral axis? Because this instrument is able to give us what we call rate of turn
Rate of roll.
and rate of roll. Right?
Mhm.
So, just like the VSI, right? If it weren't canted, it would be nothing more than an attitude indicator,
Mhm.
right? But since it's canted, it's able to give us rate of turn, rate of roll. And this is how we are able to give our constant rate turns, right? Through this instrument. The gyro's canted laterally, it's canted 30 degrees on the lateral axis, right? Of the aircraft. So initially when this instrument, when we bank, right, it gives us a rate of roll. Once the instrument stabilizes, it's able to then give us a rate of turn, right?
Mhm.
This instrument also gives us more information with the ball that's located inside of it, right? It's able to give us slip, skid information. Make sense?
Yeah.
Alright, cool. Gotta move on. Running out of time.
Take a picture.
Yeah, let me take a picture. I think I need to go write these notes in detail, I guess.
Good?
Good.
Alright, cool. Got it? Okay. Alright, moving on. Got 28 minutes. Or 26 minutes. Alright, so we're gonna talk about how a VOR works, right? How about that? VOR. Forgot about that. So VOR and GPS. Alright, so, and equipment, I forgot about that. Alright, so how does a VOR work? So, a VOR, it looks like a little upside down sombrero. It's got the little hat right there, something like that. It's a little station there. So this is a VOR, right? What does VOR stand for? What does VOR stand for?
Very high frequency of rate.
Range, yeah.
Yeah.
Omnidirectional
Omni
Range.
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 Now, if you knew that, you would know exactly how it works based on the name.
Yeah.
It's a very high frequency omnidirectional range. Now, what does omnidirectional mean?
Every direction.
Means that it transmits in every direction, right? Just like the
Yes.
sun, right? The sun has rays, right? A VOR has rays, right?
Mhm.
Same deal, right? So it's giving you radials, just like a sun, it radiates radials. Radiates radials. Alright, so there's some different types of VORs, right? So we have VORs, VOR DME, and we have what they call a VORTEC. Right?
Yeah.
So what is VOR? Just a normal VOR, right? Without DME. Now what is DME?
Distance measuring equipment.
DME is distance measuring equipment. Alright, so what is VORTEC?
We have
So it's a
for-
VOR with what?
for meter, I think.
What's the,
10.
what is that? The TAC.
T.
TACAN, right?
Yeah.
So what's, like you said, for military use, right?
Mhm.
Okay, so how does DME work? Edwin, how does DME work? Okay, so this is our airplane. How does DME work if this is the VOR?
DME sends a straight line with the
Straight line?
Vertical.
So it sends it like this, right?
yeah.
What do we call that? It sends the information in slant
Slant
range.
range.
Slant range, right? So that's how DME works. So DME gives us information in slant range. Alright, so, what is slant range?
Range is slanted.
Exactly, so, if this information, right, let's say that slant range says that we are 1.5 miles away from the VOR, right?
Mhm.
Now GPS says that we have GPS on board, right? Our GPS says that you're actually 1 mile away from the VOR.
We are, yeah.
So that's now a limitation, right? Because the information's in slant range, right?
What do you call that? LMI, limitation? LMI?
No, I said 1 mile.
Oh, 1 mile.
Yeah, this is
1.9.
5 miles. Right? So how does DME work? It gives us the information in slant range.
Slant
Now,
range.
how does it give us that information? What is the process called? So, do you know? What is the process called?
Very high frequency.
No. So, it sends the information here, back here, here, back here. So it uses time and speed, and it equals distance. Gives us distance, right? Speed
Okay.
equals distance times time. So it's actually speed divided by time. So, it gives the time divided by speed equals distance.
No. Time speed.
Speed equals distance times time. So it'd be time divided by speed equals distance.
No. Time speed
Draw the
equal
triangle, the
distance.
DST triangle.
So speed
time.
Draw
Time
the triangle.
equals distance times time, right?
No. The
You just
equal
draw-
distance.
Just draw the triangle.
What's the triangle? Make this quick. I gotta go fly.
No.
Distance, speed, time. This is times, this is divide.
Divide.
So
Divide
if
by
you want
time.
distance, speed times time. If you
Oh,
want
speed times
distance
time.
divided by
Okay, so I was
speed,
wrong.
you want-
Okay, alright. Really, guys?
Yeah.
Alright, so time equals, distance equals time times speed times time, right?
Yeah.
Okay, there you go. Alright, so what is that process called? What is it called? It's called azimuth. 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 So it uses a process of time, speed, distance to give you time. So it sends a signal here. Let's say the airplane sends a signal to, or VOR sends a signal to the airplane and back to the VOR. That distance, or that time that it took, based on the speed that it took, will give you the distance, right? Let's say, okay, you're actually 1.5 miles away from the VOR. But like I said, the limitation is it's in slant range. Now, what's some more limitations of the VOR? What's some limitations, more limitations?
If stride a mountain, the
What is that called?
obstacle.
No. It's called line
Can't stride.
of sight.
Line of sight. Okay.
So, line of sight is VOR has to have no obstructions. No obstructions.
No, so no mountains and stuff like that.
Yes, so line of sight, just like this remote, right? You aim the remote right at the TV, but if you aim the remote over here, the TV
Okay.
won't turn on.
Mhm.
Right? That's line of sight. All right. Let's see, line of sight. What's the other limitation of the VOR? Still gotta talk about GPS.
You can say.
All right. So, reverse sensing.
Reverse sensing.
And what happens when we fly over the VOR? What is that called? The cone of confusion. So reverse sensing is if we're flying, let's say we're tracking a radial outbound with a 2 indication, right? It's going to give us reverse sensing. So we're flying away from the VOR with a 2 indication, that will give us reverse sensing.
Yeah.
Cone of confusion, right? Cool. Any more questions? Take a picture. We gotta keep going. Gotta keep moving. All right, GPS. We're gonna talk about GPS. GPS first. All right, GPS. So, GPS. GPS, right? GPS is global
Position.
positioning. Positioning system, right? So, you think about our Earth, right? There's satellites around the Earth, right? How many satellites?
24.
24.
So it's 24 satellites, right? That are able to give us information. So here's our airplane flying in the world, right? We're flying in the world. So how many satellites give us a 2-dimensional picture?
2, 3.
No. How many satellites give us a 2-dimensional picture?
5.
No.
3.
3, 4.
3 gives us a 2-dimensional picture. So 2D. 3. So 3 gives us a 2-dimensional picture. So how do we get a 3-dimensional picture?
4.
4 gives us a 4-dimensional picture, sorry. No, 3-dimensional,
3.
sorry.
Yeah.
4 gives us a 3-dimensional picture. So, how do we get rain?
5.
5, right? So 5 gives us rain. What is RAIN?
Forgot.
Receiver Autonomous Integrity Monitoring. What is that? You sure you're gonna be ready for today? We don't have to do it today. I can give you more time to study.
Okay.
Okay.
It's for stage 1.
This is all stage 1, yeah. You gotta know all this. This everything I highlighted.
Wait, you're taking a stage 1 test?
Huh?
Are you taking him for stage 1 check?
Yeah, he's doing a recheck today with Rashad.
Oh,
Yeah, Rashad won't pass you if you don't know all this. You gotta know this.
He didn't ask the VOR GPS.
He probably didn't get there.
Yes.
Yeah, he probably didn't get there. So, how many satellites require RAIN? 5, right? Alright, so what is RAIN? It says it right there in the name, right? Receiver Autonomous Integrity. The key word is integrity, right? What is integrity?
like trust.
Trust, telling the truth, right? The truth. So, right, then the answer is in the name, right? So, let's say that this satellite, so GPS gives us information down to 50 feet, I believe. I think it's 50 feet. And then WAS gives us information within 10 feet. So, we'll talk about WAS in a second if we've got time. All right, so I can do another ground later on with you if you want,
Okay.
at 5 o'clock.
Okay.
You're gonna come back at 5, yeah.
I'm gonna
Okay.
come back on Friday.
All right.
Also,
So,
information.
So, GPS gives us information within 50 feet. Let's say that this satellite says that Edwin is located over here, but you're truly located, say that it says you're here, but you're truly located right here, right? What RAIN will do is the 5th satellite will see that all these other satellites are saying that you're here. This satellite right here must be telling the wrong information, must be lying. It's not telling the truth, right? So,
Wait, say that again?
okay, so the 5th satellite, right?
Mhm.
5 satellites gives us RAIN. Let's say that 1, 2, 3, 4 satellites, one of them was giving us the wrong information,
Okay.
right? Said that you were located right here,
Yeah.
but you were truly located right here.
Okay.
Because remember, GPS gives us information within 50 feet. It's gonna say that, hey, the 5th satellite's gonna come in and say, this satellite is wrong.
Yep.
These other 3 satellites are over here, they're telling the truth. You're actually located right here. So what it's gonna do is, it's gonna cancel out this satellite right here, and it's gonna give you correct information based on these other satellites.
Okay.
Alright, so it's gonna give you the correct position. Alright, cool.
But how is it giving you information based off of 3 when RAIN needs 5?
Yeah, it needs 5.
Yeah.
Yeah, it needs 5. But what if 4 was wrong? What if one of the 4 was wrong? Because 5 is just giving you the integrity of, it's checking the integrity of the other ones.
Oh, okay.
It's basically doing an interview. Hey, what are you saying? Like, oh no. And that's different from what he's saying, right? So it's just interviewing the other satellites. All right, cool. VOR, GPS. All right, so what is WAS?
WAS.
What is WAS?
What's me? WAS. W.
You'll learn about this more in stage 2. Flight is where you're gonna have to know what WAS is. But WAS is, I'm just gonna cover it because we're talking about GPS. So WAS is wide area augmentation system. So WAS is basically, we have the satellites in the air, now we have a ground-based system, right? So now we're giving even more accuracy, right? So we've got satellites on the ground. Let's say that there's a ground-based system right here on the ground. My little drawings, right?